So why don't ionic compounds have delocalized electrons like metals? When ionic compounds are formed, electrons are transferred from one substance to another. Our lithium gave one electron to our chlorine. So that electron was fully transferred to an atom. The metal gives its electron away to a nonmetal in order to achieve stability. Now these electrons will be tightly bound to the ion and thus are not free to move when ionic compounds are formed. Because the ownership of that electron has transferred, it means that now that electron is bound, it's obligated to be with this new ion, and so it's not free to move and be delocalized like in a metal. Explain why ionic compounds generally have high melting and boiling points. Okay, so similar to metals, ionic compounds have very high melting and boiling points. Well, the attraction between positive and negative ions is very strong due to the large charge difference. So you've got a really big difference in charge between the positive and negative ions. Additionally, each ion is bonded to 6 oppositely charged ions that are next to it in the lattice. So 6 ions are always around. This means a large number of very strong bonds need to be broken in order for the substance to become molten. So in order for each ion to have sufficient mobility, we need to be able to break each and every one of those bonds, or at least loosen them so that they can move. And so that means that we need to put in a lot of energy, which translates into a high melting and boiling point. Ionic compounds are generally good conductors of heat, but not electricity. Why is this so? So you imagine that you've got all this charge in this crystal. Why doesn't it conduct electricity? You've got all this charge, why don't it conduct electricity? Well, since the ions are closely packed to one another, the ions can easily transmit vibrations. That's why they're good at conducting heat, because the vibrations can transfer very rapidly. This means that the heat can be transferred effectively through the substance because of that tight packing. But ionic compounds have no free electrons, and the ions, which are strongly charged, can't move. They're immobile. They can't move through the lattice. And if you don't have any charge that's able to move, you don't have any current. Therefore, there is no movement of charge through the substance, making it a poor conductor of electricity, because you can't get any charge moving, which means that you don't conduct electricity. So when ionic substances are molten, they conduct electricity. However, when they are solid, they cannot. Explain what's happening. So previously, we just said that they can't conduct electricity in solid state. But when we melt them, all of a sudden, you can pass electricity through them. So what's going on? So in the liquid phase, the ions are more mobile than in the solid phase. This means that the ions are free to move under the influence of an electric field. So if you put a voltage across a molten salt, the positive ions will move towards the negative end, and the negative ions move towards the positive end because they're attracted that way. Now this net movement of charge is electrical current, so it allows the molten salt to conduct electricity. So you can see how that works. So when an ionic substance is dissolved in water, it allows the solution to conduct electricity. So why is this happening? What's the likely explanation for this? So when we actually dissolve salt in water, it actually improves the conductivity of that water. So what's going on? So when an ionic substance is dissolved in water, it is separated and surrounded by water molecules. So if we had a positive guy here, the other way around, what would happen is that these little Mickey Mouse water molecules would surround the positive ion and actually keep it separated from the negative ion. So now it's essentially, this unit here is free to move by itself. Now keep that in mind, that it's free to move. Now this allows ions to act as if they were in the molten state and move freely through the solution, as I mentioned. So because they're surrounded by water, they can actually drift around through the solution however they want. Now this free movement allows the solution to conduct electricity, which means that dissolving salts will allow you to improve the conductivity of water. So that concludes today's lesson on ionic bonding and ionic compounds. So we looked at how ionic bonding works, what is its structure, and where does it come from? And then in the question segment, we looked at, well, how does ionic bonding explain the properties of an ionic compound? So hopefully you can always tie those two things together, the theory and the application, and that will allow you to answer any question that you come up across in chemistry. So I look forward to seeing you at our next lesson.